So next encoding which is in pipeline for us is effect encoding. This encoding technique is also known as deviation encoding or sum encoding. So effect encoding is almost similar to dummy encoding with a little difference. In dummy encoding, we use 0 and 1 to represent data, but in effect encoding, we use three values, that is 1, 0, minus 1 that you can see on the screen. Okay, so the row containing only zeros in dummy encoding is encoded as -1 in effect encoding. So in the dummy encoding example, the city Bengaluru at index 4 was encoded as 0000, whereas in effect encoding it is represented by -1 -1 -1 -1. Okay, now let's take one example just to understand effect encoding. So this is our data set, a data set which consists of a column named after gender, and it has a values of male, female, non-binary. So now we will understand what is effect encoding with respect to this data frame or data set. Effect encoding, also known as contrast encoding, is another method for encoding categorical variable. Let me put this here. So this is used for categorical variables, similar to one hot encoding or dummy encoding, but with a slight difference in how the binary columns are created. So in effect encoding, we will choose one category as the reference category. I am writing down here. In effect encoding, we will choose one category as the reference category, and the binary columns are created to represent the contrast between this reference category and the other categories. Okay, the reference category is typically represented by -1. Let me put it here. The reference category is typically represented by -1 in the binary columns. So while the other categories are represented by 0 or 1, depending on whether they are present or absent in a particular observation. Whereas other categories are represented as 0 or 1 depending on whether they are present or absent. So let's take an example here. Let's get back. So here is an example. So using the gender variable with three categories: male, female, and non-binary. So these are the three categories under the gender nominal variable. So now let's do the effect encoding. Now, out of these out of these three categories, let's choose male as the reference category. This one, male as the reference category. The effect encoding would create two binary columns, one for female, one for non-binary. So male is my reference category, other two are binary categories. Now the male category would be represented by -1 in both binary columns, indicating that it is the reference category, and a female and non-binary category would be represented by 1 or 0 based on whether they are present or absent. And that's what had happened here. So effect encoding is commonly used in statistical analysis or regression modeling when you want to compare the effects of different categories relative to a reference category. It allows you to understand the contrast between different categories and their effects on an outcome variable. Now let's look into this. You have the male category. Obviously, it's a reference category. You got the -1, and on the binaries will be 0. And when you have female, then you look into the female categories, 1 0. So you got the female, the binary categories, then put 1 in female, and non-binary will be 0. And obviously the gender, which is uh, reference category, it should be opposite to the binary category, contrast to the binary category. That's what had happened here. Then you have the non-binary. So non-binary here. So that's the reason female become 0 and gender non-binary has become 1. And here it's exactly opposite. In contrast, gender male, the relative variable is in contrast to the non-binary. And when again male came into the picture, then it took -1, and remaining binary variables took the values 0 and 0. And again female back, female took 1 and gender non-binary took 0, whereas the gender male has took the opposite, in contrast the values. Okay, so here you got 1 and here you got the 1, in contrast to this -1, in contrast to whatever is there before. Okay, that's what is effect encoding. Now let's take a simple example. And here is that the male, you got the -1, and female it took 1, and that non-binary gender took 0. And when non-binary came, remaining things are zeros, and gender non-binary took 1, and male -1 and female 1. Okay, yes, this is the data frame that we are going to use. Let me execute this. So male, female, non-binary, male, female, and then non-binary. And this is what is our data frame. So now let's perform effect encoding. So let's choose male as reference category. That's what my first target. So for that I need to say uh, gender underscore male, and I'll also put the ref. This is my reference category just to differentiate, and df, and obviously I'll go for the gender. And then now I have to apply some anonymous function. So I'll apply anonymous function. So for that, to create anonymous function, I need to go for the lambda So lambda and -1, x is -1, x is here I'm giving allocating the parameter, and if x is -1, if x is equals to male, if x is male, then the response of that lambda function should be -1, else 1. And another condition, if x is equal to female, then just say, if x is equals to female, then give 1, or else just give 0. I hope you got my point. This is a relative category, reference category. That's the reason if x is male, then the value should be, the response of this function should be -1. If x is female, and the response of this function should be 1, else 0. Else any other thing, it's 0. Okay, that's what is, if you want, we can check it. That's what is your gender male ref. Here it is. So now let's create binary categories. It's pretty simple. So df, this time I'm gonna say gender and then female. df gender, apply lambda x and 1 if x is female, else 0. Pretty straightforward. And same thing happens with the other one. I'm just copy pasting here, but I need to change this binary. I need to put the this one as a non-binary, sorry, gender non-binary. So let me, here it's better to copy directly from here and put it there, so that there won't be any mistakes. So let me change this one. If x is non-binary, I want 0, or else if x is non-binary, the value is 1, or else 0. And here is that. You got it? Right? Male -1, female 1 1 0, non-binary 0 0 1, male -1 0, female 1 1 0, and that's what we have shown here. Male, female, non-binary, male, female. This is what is the effect encoding for us. So in this example, we choose male as the reference category and created 3 binary columns to represent the contrast between the male, female, and the non-binary categories. So the binary columns indicates the presence 1 or absence as 0 of each category in each observation, with the reference category male represented by -1 in the gender male column. So the gender female and gender non-binary columns represent the contrast between the female and the non-binary categories relative to the reference category male.